Hi, I am V. Satish Kumar. Now I am going to give a presentation on analysis and design of G+6 residential building using STAAD. Our team members are Satish, Hari, Praveen and Sandeep. Softwares we used: STAAD, STAAD Foundation and AutoCAD. We shall look into the details of the software in the next slide. What is STAAD? Our project is mostly based on this software. So let's look what is this software and what does this software can do. STAAD is a powerful design software licensed by Bentley. STAAD stands for Structure Analysis and Design. So what is the structure, analysis and design means? Any object which is stable under a given loading can be considered as a structure. So first find the outline of structure, whereas analysis is the estimation of what are the types of loadings that acts on the beam, and calculation of shear force and bending moments comes under this analysis stage. Design phase is designing the type of materials and its dimensions to resist the load. This we do after the analysis. Why do we use STAAD? To calculate shear force diagram and bending moment diagram of a complex loading beam, it takes at least an hour. When it comes to into a building with several beams, it takes at least a week. But STAAD do this just within an hour. Nowadays, most of the high-rise buildings are designed by STAAD, which makes a compulsion for a civil engineer to know about this software. This software can be used to carry RCC, steel, bridge, truss, etc. according to various country codes. Do you have any alternatives for STAAD? Of course, we have like struts, robot, SAP, SDS Pro, which gives details very clearly regarding the reinforcement and manual calculations. But these softwares are restricted to some designs only, whereas STAAD can deal with all types of loads. AutoCAD is design software where the word auto came from a company called Autodesk, and CAD stands for computer aided design. Now coming to our structure, this is an AutoCAD plan showing G+6 residential building. The area of this plat is 1120 square meters. The plan itself indicates that it is a combination of 5 apartments and each block comprises a 3-bedroom flat for each floor. In the middle it contains 4 lifts which is connected to all blocks and 2 staircases for each block. This figure indicates the center line plan of our building, indicating the position of various columns in the STAAD. This is similar to our plan. This center line plan is used for creating a skeletal structure in STAAD. This figure shows the elevation of our structure at site. This figure shows the proposed AutoCAD plotting of our building elevation. This is a flowchart diagram which gives you stepwise procedure of analysis using STAAD. Now regarding the loadings.
Hi, I am Sandeep Reddy. Coming to the loadings, we know that loads are the basic criteria which has to consider while designing the building. So let's look into what are the loads generally a building bears. Let's divide our total load into 2 parts, that is vertical, horizontal. Dead, live, snow, wind, seismic come under vertical. Wind, seismic, flood, soil are horizontal loads. We can see that wind, seismic act both as vertical and horizontal load. Seismic may also comes both horizontal and vertical. Red color indicates the type of loads we consider in designing this building. Details regarding each and every load is explained in coming slides. Next, dead load. Dead load is nothing but a self-weight of all members are the loads which are permanently throughout the operation of the structure. This load is assigned to the members by just creating a load case, giving the properties and using self-weight tool. Here it shows self-weight tool and the structure automatically turns red color, it indicating self-weight is assigned. This is how we are generally calculate dead load manually. Next, live load. Loads are which may change its position magnitude with time. Example of live load is people moving on the structure. In this building we gave live load is UDL. In the STAAD we select the type of load after creating load case and later we assign it to required parts of the structure. Here blue color indicates live load on the structure. Loads are designed as per the code IS 875 part 2. Given load is 25 Newton per mm. Next, floor load. Load on the floor is due to loads of walls and slab. Create a load case just similar to above loads and give the intensity of floor load. After applying it to the structure look like this. Next, wind load. Assigning the wind load is different to other loads. These steps are involved for the first one is creation of load case, next definition of wind load, next calculate wind intensity based on wind speed at different heights. Next, apply wind load in two direction, load transfer mechanism. Next, coming to footings. Footings are the most bottom part of the structure and last member transfer the load. In order to design footings, we use STAAD foundation software. These are the types of foundation this software can handle. Even after the analysis of STAAD, we can update the following properties if required. After the analysis of structure, at first we have to import the reactions, the column from STAAD using import button. After we import the loads, the placements of columns is indicated in this figure. After this, input various properties of the structure and click on design. After the analysis, detailed calculation of each and every footing is given with the plan and elevation of footing including the manual calculation. Output file contains the dimension of all columns and reinforcement details of all the columns. This figure shows the layout of the all footings. Here we can observe that some of the footings coincide as they are very near. In such situations, combined is laid. This figure shows the elevation showing the reinforcement details, and this figure shows plan with reinforcement details on the top and the bottom.
Hi, this is Hari Prasad. Now we look into design of different components of building. Columns. The main function of column is to transfer all types of loads from building to the foundation. In our structure, we adapted 3 types of columns, depending on the load acting on the column. This figure shows the central line diagram of building. After the design of column using STAAD, we will get reinforcement details as shown in figure. Beams. Beams are designed for bending. This figure shows reinforcement of a sample beam in STAAD. After the analysis, we get the bending moment and shear force as shown in the slides. Slabs. There are 2 types of slabs, one way and two way, which are classified based on deflection, load distribution as shown in figure. This figure shows load distribution of the building. Conclusion. STAAD is a main tool for designing a high-rise residential building. These are the references we used. Code books we used are IS 456-2000 SP16. Thank you.